This video is for Chapter 7, Section 3, and it's all about proving triangles similar. In our previous lesson, we discussed what similarity means, or similar polygons. What we're going to be dealing with today is just looking at similar triangles. Now, to review, similar polygons meant you had to have the same shape. We're going to go over two things: same shape, same size. And we discussed this as being that this meant congruent angles and this meant proportional sides. Now, this is important because we saw that a rhombus and a square can have proportional sides. All four sides of a rhombus could be 8 and all four sides of a square could be 5. The ratio is 8 to 5. But because the angles aren't the same, they're not similar. We also saw that a rectangle and a square can have the same angles, where they have right angles the whole time, 90, 90, 90, but their sides are not proportional. So we're used to saying that you have to have both of these to be similar. However, triangles are similar. Triangles are a little different. Triangles don't need to have both. Triangles only need to have one. Either they have to have congruent corresponding angles or sides proportional, and there's one way that's somewhere in between. So our lesson is, how do we prove triangles similar? The first one is to remind ourselves that when you look at these three triangles, I've only given you two angles in each triangle. Yet, we can decide that these triangles have all three angles exactly the same. We have 60 and 70 here. 180 minus that 130 gives us 50 for the third angle. So the third angle of our triangle is 50 degrees. Now, we have 60, 70, and 50. This triangle has 60 and 50, which lets us know that the third angle must be 70. And this triangle here, 50 and 60, well, that lets us know that the third angle must also be 70. Now, these triangles have the same angles, and this is enough to say they're similar, because the angles controlling the shape, we cannot alter this. Each side is connected to the other two sides. So all we need is all three angles to be the same, and these triangles will be similar to each other. This is what we call angle-angle similarity. It's not angle-angle-angle because we only need two angles. So we will say, if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. Then the triangles are similar. Now, this comes at after making sure we understand a really important statement, which is, as long as two angles of one triangle are congruent to two angles of another triangle, the third angle is congruent. So don't forget the third angle theorem. You can look that up if you need to. If two angles of one triangle are the same as two angles of another, we know that the third angle is the same. So as long as we have two angles of one triangle congruent to two angles of another triangle, then the triangles are similar. This is called the angle-angle similarity. That's one of three different ways to prove triangles are similar. Our next one is to take a look at these two triangles. We have triangle ABE, and we want to compare it to triangle ACD. We're trying to figure out if they're similar. One thing we know is they both have angle A. Right here, angle A, they are shared. If we were to separate these triangles, you have triangle ABE, which is the smaller one, and you have triangle ACD, which is the larger one. We know that they share this angle, so they have one angle. And we also know that the sides are 6 and 8, But over here, we'll put the whole length. We'll say 9 and 12, 8 and 4. So in this case, we have one angle and the sides that are around it. Kind of looks like side angle side, except they're not congruent. So we're going to look at side angle side similarity. If the sides that surround the angle are in proportion with each other, then we have similar triangles. 6 compares to 9 the same way that 8 compares to 12. This becomes 2/3 equals 2/3. Check. We have side angle side similarity. And what we can say here is the similarity ratio is 2 to 3. Okay. To recap side angle side similarity, if one angle of a triangle is congruent to one angle of another triangle, okay. We're going to say if one angle is congruent to another angle from two triangles and the sides surrounding them are proportional, then the triangles are similar. And the sides surrounding are proportional. A lot on the board here. Then the triangles are similar. Triangles are similar. Okay, there's method 2. 1, angle-angle similarity. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. This will be a majority of the time. Second method, side angle side. 6 is to 9, the left side, as 8 is to 12. Okay, so that's side angle side similarity. Our final one is side similarity. Side similarity is talking about, well, what if we don't know any of the angles, but we know that the shapes are proportional to each other? In this case, you have the shortest side compared to the medium side compared to the long side. Well, 3 compares to 6 the same way 4 compares to 8, the same way 5 compares to 10. These all reduce to 1/2. This is the similarity ratio, and this confirms that there is side similarity. If all 3 sides of one triangle are proportional to, we're going to have to say all 3 corresponding sides, so are proportional to all 3 corresponding sides of another triangle. I'll switch over here. Another triangle. Then the triangles are similar. Okay, so we've learned the 3 ways. Angle-angle similarity. If you get 2 angles and 2 triangles, that's enough. They're similar. Side angle side, you have to have one angle and show one proportion. Side angle side. Side, we need an extended proportion. We need all 3 sides to be equal ratio, and that will give us similar triangles. Now what we're going to do is take a look at examples of how you decide whether triangles are congruent, or not congruent, but similar, and how we can use the similarity to maybe find a missing side. This will be exactly the same as the previous lesson, except we're just going to address one of these 3 things. Okay, let's look at 3 quick examples of how we might use this material. The first question will be, are these triangles similar and why? We'll start with these triangles here, A, B, C, D, and E, like the previous picture. So the question is, are they similar? We might think this is the side angle side example, but that's not it. We have to say, okay, are there any angles that are congruent? Yes, they share angle A. And then the parallel lines, that should jump out at us. Parallel lines, corresponding angles, alternate interior angles. Here are some corresponding angles. So I have angle A congruent to angle ABE, or sorry, angle A to A, angle ABE to angle ACD. So triangle ABE is similar to triangle ACD by angle-angle similarity. This was not side angle side, because if I tried to create side angle side, I would have 9 compares to this whole thing, which is 12, the same way that 12 compares to 12 over 12 plus x. This is 12 plus x. This is a difficult problem. We cannot show that these are similar. So, angle-angle is y. The proportion is how we will solve for x. Cross multiply, we get 144 equals 12 times 9, which is 108, plus 9x. So we cross multiply, and we have ourselves an equation. We can subtract 108 from 144, and so by doing so we end up with 36 is equal to 9x and 4 equals x. This makes sense. We put a 4 in here, that would change this to a 16, and now we have proportional triangles. So angle-angle was why they were similar. Then we used proportions to solve for x. So how about triangle ABC and EDC? What about these being similar? Well, I think let's set up the ratio. The shortest side is 4. It seems to be linked with 12, the shortest side. Then there's 5 and 15. But then there's 6 and x. Now I know that 4 is linked with 12 because 12 is less than 15 and 4 is less than 5. But the problem is I can't use side, side, side. Side, side, side is out. I can only focus on these two. And they seem to both reduce to, well, 4 over 12 is 1/3, and so is this, 1/3. Well, there's the similarity ratio, but it's not side, side. Vertical angles. With the vertical angles, we can now say that because of what is in the box and the vertical angles, triangle ABC is similar to triangle DEC by side angle side similarity. And now if we want to solve for x, we can use our similarity ratio 1/3, and it should equal 6 over x. A quick cross multiplication, and we see that x equals 18. Again, why are they similar? Side angle side similarity. We use the proportion to solve. Last problem. In this case, I have two triangles leaning up against each other, but I have all the different side lengths. The smallest triangle has a small side, a medium side, and a long side. The larger triangle has the smallest side of 10, and a medium side of 12, and a long side of 16. If we set these equal to each other, they all reduce to 1/2. This is the similarity ratio, and we can say triangle ACB is similar to triangle, well, let's see, A matches up with X because it would go across the 6 and the 12, or not X, but ECD by side, side, side similarity. Lastly, we can say x is equal to 30 degrees because those are corresponding angles. Those are your 3 examples. These by angle, proportion to solve. By vertical angles and a proportion, we have side angle side, proportion to solve. By an extended proportion, we have side, side, side. We use corresponding angles to solve. That's it for this video lesson. We will work on examples in class.